Satish, can I record?
Yes, sir.
Okay, thank you.
Okay.
So we were discussing clampers. Okay, we will do a few more problems on clampers. So clampers means you have a diode along with a capacitor. Okay, so this is your resistance R is given to me. Here I have a say source. Okay, and here I'm connecting a diode. See, this value is 500 kilo ohm. Okay, it's too high. 500 kilo ohm. This is my capacitor, and here I'm applying a square wave. Okay, my V input is a pulse, a square pulse. Okay, so for example, this is my V input, which is a square pulse of 1 millisecond, and then I have a so this is 10 volt magnitude. Okay, and the time is 1 millisecond pulses. Okay, this is 1 millisecond, and in between there is a gap of 1 microsecond. Okay, so now I want to find, okay, how my output will look like in these periods. Okay, visible, no? Okay, so like yesterday, our last class, we discussed. Okay, so whenever you apply a pulse, okay, first thing what will happen, your capacitor will charge and your diode will be short circuited because diode is conducting for positive cycle. Okay, and once this is charged up to peak value of this input pulse. Okay, once this is a BP, then your diode will be always in reverse bias, and we can replace this by a open circuit. Now you can see that the RC circuit, RC value is how much? RC value is your, if your diode value is given by 10 microfarad, 10 nanofarad. Okay, if diode capacitance is 10 nanofarad. Okay, in that case, what will happen? Your RC is 500 kilo ohm, and you have 10 nanofarad. Okay, so what will become? How much RC will come? Okay, so this is 10 raised to power 4, 10 raised to power 4 and 2. How much will become? 10 raised to power 6. Okay, so how much should come? Tell me please. It's coming 5 milliseconds. Okay, it's coming 5 to 10 raised to power minus 3. Okay, 6 and minus 3. This is your 5 millisecond discharge time. And now you know discharging time is at least 5 RC. Discharging time is at least 5 RC. This is 25 milliseconds. So from here you can see that the charging time is 1 millisecond. Okay, once this will go in so it will pulses. Okay, so only for this time, this small time period, your capacitor will not be charging. Okay, this is only 1 microsecond, and compared to this one, this is too high. So the charging time is very high compared to this 1 millisecond and this cycle, this time period of the cycle. Okay, so once this is charged, it will not discharge. Okay, completely. Once this is charged up to peak value, this will make this diode to be reverse bias, and this will become open. Now here you can apply your KVL. Okay, so say this is my V input. Okay, so this is my V input, and then you have a VP, and then you have equals to V naught, isn't it?
Why we have 5 RC?
This is basically a capacitor discharging time. Okay, whatever the RC depend on how capacitor will fast discharge, fast or slow, that depend on RC constant. Okay, so generally we take up to 5 RC. We assume that the discharging time is 5 RC. Okay, so this is a fixed value. Okay, minimum it is a 5 RC. Okay, so if you put a low resistance, it will discharge fast. If you put high resistance, the discharging period will be slow. Okay, now you can see the V naught. If I want to find V naught from this equation, so my V naught will come how much? Is this equation correct? Let me check. Okay, this will be 0. Okay, because here this is a V naught. So V input plus VP plus V naught. Okay. So my V naught will be how much? Can you tell me what will my V naught? Am I writing the equation correctly or not? If I want to write,
माइनस वी इन आएगा ना, माइनस वी इन
yes, correct. Now it's correct. Okay. Minus V input plus VP plus V naught. Okay. So V in output become my VN, V input. Okay. Minus VP. Now put your VP here. Okay. VP is 10. Okay. V input is your what? How much? So when this is a 10 millisecond pulse. Okay. What should I get output? Tell me. What will the output? What is the value of output now? Peak value is how much? Peak value is your 10. Okay.
10.
Peak and V input is also 10 in this period. It is fixed. So what should I get? I should get zero output. Okay. And when this is zero,
क्या ली है?
peak value तो इसका peak value तो यही 10 ही है ना? Peak value will be 10 volts. Okay. When it is 10 volts, okay, the output will be 0. Okay. And when it is 0 V input, I get V peak. So my output will be like this. Minus 10. Can you see?
सर
हाँ बोलिए.
सर हमें ये जो ग्राफ पे V इनपुट 10 वोल्ट दिया है तो
हाँ.
VP कैसे लेंगे सर?
VP मैक्सिमम कितना चार्ज होगा?
10. ओके
ये तो ओपन हो गया ना, तो मैक्सिमम कितना चार्ज होगा? मैक्सिमम VP तक चार्ज होगा ये. ठीक है. सो जब अब पूरा ही चार्ज हो गया VP तक, तो यहाँ ऑब्वियसली जीरो ही आएगा. सो व्हेन इट इज VP इट इज जीरो. ओके. एंड if it is 0 minus VP. Okay. So like this will be
सेकंड केस में 10 raised to -6 minus 10 raised to -3 ऐसा ही कैलकुलेशन आएगा ना
कैसे?
वी आउटपुट का 10 raised to -6 minus 10
minus
raised
6
to
10 raised to 6 10 raised to 6 क्या है?
10 raised to -6
10 raised to -6 क्या है?
1 माइक्रोसेकंड है ना वी इन, वही लेंगे ना हम.
वो तो टाइम पीरियड है ना. हाँ ये टाइम पीरियड तो बराबर रहेगा. ओके. टाइम पीरियड तो बराबर रहेगा. ओके. व्हेन यू हाई then again you get low. Okay. When you have this low value, okay, you get this output. हाँ बोलिए.
Simply we can take maximum value or minimum value.
मैक्सिमम वैल्यू ना, बस भी कहाँ तक चार्ज होगा? इट विल चार्ज अप टू
10 volt.
10 वोल्ट. उसके बाद बंद हो जाएगा. once this is equal, okay, that will not charge further. Okay. Now this voltage and this voltage balancing. Okay. That means now here no current cannot flow. Zero current flowing. That means it's open.
circuit.
This is zero current. Okay. So no voltage. Okay. Here. So you get here like this up to charge here. So when you are higher voltage, you getting zero output. Current is zero. When you are zero, okay, then next cycle zero, then you're getting maximum. So now what you're doing, you are shifting this one. Okay. Shifting by 10 volt. So this is clamping. Okay. Negative clamping. Okay. You make it properly. I have made drawn little bit tilted. Okay. You just make straight one. So if any question,
नेगेटिव वोल्टेज -10 वोल्ट ही है ना,
नेगेटिव वोल्टेज यहाँ पे है कहाँ? ये तो पल्स है ना.
मतलब हाँ जो डाउनवर्ड शिफ्ट हो रहा है वो 10
हाँ.
वोल्ट का ही हो रहा है ना.
ये -10 वोल्ट माइनस clamping of -10 volt. Okay.
Sir,
हाँ.
can you explain once more graph, sir?
So see, this is your output minus V input plus this one capacitor charge. Okay. And then this one. Okay. How much is voltage coming? V naught here. Okay. So this is the equation for V naught. So V naught is Vn minus Vp. Okay. So when you are applying V input is 10 volts. Okay. Vp is also 10. So this 10 becomes 0. You got 0
How
here.
did you say P input was 10 was?
When V input is pulse only, na? Where is there's not sine wave. There's no changing wave. It's a fixed voltage, fixed pulse.
Okay. Okay, sir.
Okay. So it's fixed pulse. So you're getting 0 here. Okay. You're getting 0 putting your from this equation, you're getting minus Vp. Okay. So this pulse is negatively clamped, negatively shift. Okay. let me do one more problem. This capacitor is given 10 microfarad. You have resistance say 10 ohm. Okay, and this is your V input, and this is your diode. Okay, okay. So this is given your Gino diode of 6.8 volt, and this is silicon. Okay, you take 0.7 for this one. Okay, and here you are taking output. So, and input is again given a pulses. This time negative also, positive also. So you have 14 volts, 1.4, and here you have minus 1.4 volts. Okay, and you want to plot output. Okay, so how can we plot the output? Okay, so this is VC. Okay, this is maximum 14 volts. Okay, now tell me, if I want to flow the current, okay, then what is the condition? If I want to flow the current in the circuit, if I want my capacitors to charge, so what should I do first? If current has to flow through the circuit, okay, what is the condition? Can anyone tell me? What is the condition?
सर 6.8 से ज्यादा
Hmm.
पॉजिटिव वोल्टेज लेंगे हम.
हाँ, so
6.8.
you all,
7.5.
so already you have 14 volts. Okay, so if you want this diode to make conducting, okay, obviously what should be there? Okay, you should apply this one. So this is, so you're applying this voltage. Okay, so whatever voltage come here, that same voltage come here. So that should be, you have to replace by battery. So you should come 0.7 volt here. Okay, and here I want to replace by a battery of 6.8 volt. Okay, so 0.7 and 6.8. Okay, you must apply this one. The remaining will come to here. So now this time your capacitor will charge. This become how much? 6.8 and 0.7. How much become? 7.5. So 7.5, 14 minus 7.5. So your capacitor will charge now up to 6.4 volt. Clear? Okay. So this is now my condition. So I can write now. This is my positive cycle. Okay, for positive cycle, I can write
Sir?
my V. हाँ.
जीना डायोड का जो वोल्टेज है उसका डायरेक्शन ऑपोजिट होगा ना?
हाँ, अपोजिट होता है ना. जीना डायोड का हमेशा जो नेगेटिव ऐसा होता है, तो इसी को हम बैटरी से रिप्लेस करते हैं ना. नेगेटिव बैटरी नेगेटिव को प्लस से और माइनस से, क्योंकि जीना डायोड ऑलवेज वर्क्स इन रिवर्स बायस ना.
तो यार नेगेटिव वोल्टेज ऐड कैसे होंगे?
नेगेटिव वोल्टेज थोड़ी ऐड हो रहे हैं, आप तो रिवर्स बायस लगा रहे हो ना. जहां वोल्टेज आ रहा हो, ये रिवर्स बायस लगता है इसमें, और क्या.
यस सर.
ओके, सो
सर
पॉजिटिव साइड
6.5 कैसे आया, एक बार बताइए दोबारा.
ये कितना है? 6.8, ये 0.7.
0.8.
ओके, टोटल इज हाउ मच? 14. ओके, 14 है तो बचा हुआ कहाँ पे आएगा? यहाँ पे आएगा. अब चेक कर लो ना भाई, आपका V इनपुट कितना है? माइनस V इनपुट. ओके, प्लस से VC. ओके, एंड दिस इज प्लस हाउ मच? दिस इज 7.5. 0. Okay, now what your VC will come? Your VC will come V input minus 7.5. Now V input is 14 volt. Okay, minus 7.5 volts. This will come 6.5 volt. Okay, so now you know what is your VC. Okay, now suppose you are changing the sign. So how much output I should get? So when this is a forward bias, okay, I'll get output equal to 7.5. I get output equals to 7.5. Okay. Now what happened in reverse bias? Tell me. What become reverse bias? रिवर्स बायस में क्या होगा बताओ?
रिवर्स
Diode
में
will act as an open circuit. Complete voltage will.
So reverse bias said this is my minus plus. Okay. So now if I put the reverse bias, okay, for negative cycle, okay, how should I write the equation? This will become open because both will be open. Okay, because this diode is open, so obviously no current will flow in the circuit. Okay, so now what will become? This plus, this 0. So again you can write this from start here, minus V input, okay, plus minus V naught, okay, and your minus VC is always like this, minus VC equals to 0. So your V output will be now, okay, V input, okay, V input and plus VC, and V input is how much next cycle? 10 volt, 14 volts. Okay, so how much will become? Tell me.
minus 14 volt.
Minus 14 volt, and VC is how much?
7.5.
No, it's not 1.5. Just check the sign again. Okay, so how I'm writing? I'm writing for second cycle. This plus minus. Okay, so this is
14 volt
6.5. Wait. Minus 14. Okay, minus तो मैंने यहाँ put कर दिया ना. माइनस तो मैंने ऑलरेडी पुट कर दिया यहाँ पर ना.
माइनस में से क्यों आएगा? प्लस
माइनस प्लस से आएगा, प्लस 14 ही आएगा. ओके, माइनस साइन आई ऑलरेडी टेकन हियर ना, साइन आई ऑलरेडी टेकन हियर. ओके, नाउ वी सी 6.5.
सर तो मिनिमम वोल्टेज भी तो माइनस 14 वोल्ट है ना.
हाँ भी तुम
साइकिल का मिनिमम वोल्टेज भी तो माइनस 14.
भी तुम दो बार साइन थोड़ी चेंज करोगे. दो बार साइन, या तो तुम एक बार इक्वेशन
साइन चेंज.
तुम यहाँ पे इक्वेशन लिखो, तुम्हारा ये इक्वेशन रहने दो. वी इनपुट है तुम्हारा. ओके, से माइनस वी इनपुट. ओके, से वीसी से वी नॉट इक्वल्स टू 0. ओके, ये इक्वेशन रहने दो. नाउ वी आउटपुट इज हाउ मच? योर वी आई माइनस वीसी. ओके, now vi is your negative. Now you want to put with sign, you put negative next time. Minus 40, minus 14, and minus is this 6.5. So how much it should come? How much? 20.5. Okay, so this will come now your minus 20.5. Now minus 20.5 here, and the 7.5 total is become how much? 28, and this is also 28. So this peak will be only shifted. Okay, इनका वैल्यू चेंज नहीं होगा. जो गैप है, द डिस्टेंस पीक टू पीक वैल्यू इज सेम. हियर इज 28, हियर इज 28. दैट विल मेंटेन. ओके, so you have to always remember that we are measuring voltage like this. Okay, we are measuring voltage like this, but when we are changing the sign is also changing. Okay, so this voltage is maintained, this voltage is maintained, so I am keeping this maintained. Only this sign is changing. Okay, so when it's positive, you put positive, and negative. If it is positive, you how much you output? You get output 14 minus 6.5, you get 7.5. Okay, when it is negative, you are getting negative. Are you getting? Okay, now if you want to put you want to write separate equation, then you have to keep mind that your v naught is not like this, your v naught is like this. We did mistake, that's why it came problem. Okay, so
सर ये जो अभी बताया ना, वो एक बार प्लीज बताना. यहाँ माइनस साइन हमने नहीं लिया है ना, वी नॉट को पॉजिटिव लिया है.
I made one time equation, but this is always maintained. VC is always maintained, isn't it? VC is always maintained. V output always we are measuring like this. So only sign this changing. One time is positive, one time negative. So I made the equation. One time I put positive, one time negative. If you want to put separately, then you again write the equation. So this is for positive cycle. Okay. Now let me write this for same again for this for negative cycle. Okay. Same thing is there. Now I'm writing negative cycle. Okay, negative cycle. This is plus, this is minus. Say minus V input. Okay, now I already put the minus. Okay, now your V input is also V output is also minus. Not like this. It will come like this. I am measuring like this. Okay, so this V naught, and then your minus VC equals to 0. Okay, now V naught will be how much? Minus V input minus VC. Now put the values here. How much? Minus 14 minus 6.5 whatever. Okay, so minus 20.5. So either you use that equation or this equation, both are same. Okay, here minus, if you're writing minus, is minus came. That was positive, so you have to put minus here. Clear? You cannot make 2 times minus, 1 time minus here, and again 1 time minus. That 2 times you cannot do. Okay, this is minus already for this minus, already minus cycle. I'm only changing the sign. Na? Okay, please tell me any doubt. Anyone?
सर
हाँ,
जेनर
हाँ.
डायोड का वोल्टेज कैसे 6.8 आया?
Zener diode cannot conduct until you don't apply Zener voltage to it. Okay, Zener diode cannot conduct. We have discussed when we are discussing Zener diode. Okay, so you know I have several times discussed. This is your Zener diode working. Okay, so until you don't apply a breakdown voltage, it will not conduct. So before that, there is almost only reverse saturation current is flowing. Okay, the minimum current is flowing. Minimum current is flowing. किसका मतलब क्या है? That is open. Microampere current is flowing. You want diode to conduct, there should be minimum voltage. Once this minimum voltage is applied, it start conducting. Okay, without resistance. That means you can replace it now by a battery. Clear?
Okay, sir. Thank you.
Like your ordinary diode, you're replacing by 0.7 volt. Similarly, you are replacing Zener diode by its Zener voltage. Okay. So these were the examples. Okay. Now let me discuss another topic. So this was a clamper. Okay. Please try some problems of clamping. Okay, I'll send today, and then I'm going to next topic. Okay. Small signal model of diode. Small signal model. Okay, for diode. Now, what is a small signal model for diode? Okay, for example, I have a resistance R. Okay, and applying voltage V. Here resistance R and ID current is flowing in the circuit, and there is a voltage drop VD. Okay, across the diode. So now, if I see my diode, okay, IV characteristics. So how can I plot IV characteristics? Okay, this will be the ID. Is IV characteristics? This is I. This is V. Okay. So how much current will be flowing in the circuit? This will be decided by this resistance. Suppose this ID current is flowing in the circuit. Okay. And VD is the voltage, minimum voltage required diode to conduct. Okay. So in this case, you can see every point diode resistance is changing. VD is fixed, for current is changing. Okay. So diode in a circuit has a two type of resistance. Okay. One is called DC resistance, DC or static resistance. Static resistance. And second is called your AC or dynamic resistance. Okay. Now, what is your DC resistance? So DC resistance, this is your DC resistance. Okay, your RD. Okay, RD is your VD upon ID. How each point it varies. Okay, this is your DC resistance. Okay. Now, what is AC resistance? Okay. Now, for example, here,
Sir, it is fixed na VD and ID. Then
And
it will be fixed.
it will fixed for given this resistance will decide na how much current in the circuit. Are you getting?
Okay.
If this VD is fixed,
Yes.
but this resistance decides how much current flow. Okay, if this much current is flowing, it depends on ID value. Okay, how much current is flowing in the circuit. So each point is changing. The current voltage is fixed, but current will keep on changing. So it is not like a normal resistance. The diode resistance always varying. Okay. So this is
Sir,
called your
VD is also not fixed. As we
which
go
one?
forward, VD also changes along that graph.
VD is cutoff voltage. Okay, cutoff voltage. Like for silicon, it is 0.7. Okay, for germanium it is 0.6 fixed. Okay, some other diode may be something else. Okay,
Sir,
so this is
that ID in the formula, that ID VD upon ID, जो ID अपने ग्राफ पे लिया है, और this coming ID is different, मतलब ना?
this ID is how much current is flowing through a diode.
हाँ
Okay,
जी, हाँ जी.
once diode is conducting, okay, how can you write this equation? If this diode is conducting, okay, you can replace diode by a voltage called cutoff voltage or VD. Okay, generally we take 0.7 for silicon, but this is not a silicon diode. Okay, any general diode, it is VD R, and this is V, and this is my ID. Okay, now if you want to write how much current is flowing in the circuit, I would like minus V plus ID RD plus VD equals to 0. Okay, so ID will be how much? V minus VD upon RD. Okay, so depend on resistance, how much current flow. Okay, depending this point, the operating point, this resistance will decide what is the operating point. This is the operating point, or this is the operating point, or this is the operating point. Clear? Okay, so each point we have different resistance. Okay, depending on the circuit conditions. So this is called your static resistance. Okay, now suppose now in this same circuit, if I put a AC source also, a small signal AC source. Okay, I am putting a AC source. Okay, say I am calling it now VDT. Okay, this is small a small AC signal I am putting here. Now what will happen? Okay, so you have already some current flowing in the circuit here, isn't it? You are applying some voltage. Okay, say this voltage is V0. Okay, you are applying some voltage here. Okay, now you're applying this extra voltage here with time varying voltage. Now here the voltage will change. Now the here whatever voltage will be, that will be time dependent, isn't it? Depending on how it's varying, this is fixed. How it is varying, this will also vary, isn't it? Vary or not vary? Tell me.
Yes, sir.
Okay, so now suppose I am applying a AC signal, and this is a DC signal. So if I am applying this positive cycle, okay, current in the circuit will increase, isn't it? And if it is negative coming, then current in the circuit will decrease, because once I make this positive, this will add here, and once I make this negative cycle, this will opposite to this one, so this will decrease the current. So what will happen now? This point will change in the circuit. This point will vary, isn't it? Okay, so this point will vary means, now let me say this is my ID. Now about this point,
Sir, can you explain once more this input, sir?
yes, I'm explaining. Now suppose I'm applying a small signal. Okay, let me take this point here. Okay, now when I apply the battery, some circuit is flowing in the current, this one. Okay, now along with this voltage, if I'm applying a AC signal, okay, AC signal like this. Okay, I'm applying AC signal, or square wave or triangular wave, whatever. I'm applying AC signal. So when there is a positive cycle, okay, this will add, this will be in the direction of this battery. Okay, so this voltage will increase. So you get increased current here. So you will get this current here. Okay, similarly now similarly, if you are applying negative cycle, your current will decrease. You'll come to this point. That means this point is shifting. Okay, because your voltage is increasing, your ID is increasing, so this point is shifting from positive here, negative is coming here. Okay, so what I can draw now, if I draw like this one, so I can, this is my AC signal I am applying here. Okay, so with the AC amplitude, this resistance is also varying. This is called your dynamic resistance. Okay, so now if I want to write what is my dynamic resistance, okay, so dynamic resistance Okay, how can I write? I can write this delta ID upon delta VD or DID upon DVD, isn't it? Now, how much is voltage across this diode VDT and how much current will flow in the circuit? The ratio of this one to will call your dynamic resistance. Now, I want to calculate this dynamic resistance for the circuit.
सर
DD by
हेलो सर
Hmm.
प्लीज एक बार ग्राफ बताओगे क्या मतलब
सर
आरजीबी के
VD by ID नहीं आएगा?
Sorry, VD by VD by ID. Sorry, I was writing opposite. Del VD by del ID. Yes. हाँ. B ये AC. This is the fixed voltage. Now I am applying AC voltage na extra some amplitude. Like say this is 5 volts, and now I'm applying some 5 millivolt amplitude extra. So positive cycle how much will become? 5 volts plus 5 millivolt, and for negative cycle it will decrease. So if voltage is increasing, obviously current will increase. Na voltage ID is what? B minus VT. So now you are applying some extra amplitude, time varying amplitude. Okay. So what will happen? Your current will also vary in the circuit. Okay. Small. This point will change, and the ratio delta ID, this delta ID, this is difference. Okay. And this the extra delta what you are applying here, delta VD, the ratio of these two quantities called your dynamic resistance. Okay. Now I want to calculate this dynamic resistance. Okay, clear? Is clear or not? It is clear or not? Tell me.
मतलब पॉजिटिव साइकिल में एसी करंट ऐड हो जाएगा और सेकंड नेगेटिव साइकिल में माइनस हो जाएगा।
माइनस हो जाएगा बस। ये पॉइंट थोड़ा सा वोल्टेज आपने बढ़ा दिया तो यहाँ आके थोड़ा सा कम कर दिया।
शिफ्टिंग पॉइंट की
शिफ्टिंग होगी बस। ओके
सर,
हाँ
सर मतलब पॉइंट की शिफ्टिंग होगी तो करंट भी शिफ्ट होगा।
हाँ पॉइंट की शिफ्टिंग तो करंट भी शिफ्ट होगा ना।
सर फॉर बोथ सिग्नल्स ना,
बोथ सिग्नल्स तभी तो आपका ऑपरेटिंग पॉइंट चेंज कर रहा है, वेरी कर रहा है। यस
The VD would decrease in the negative cycle.
Yes. Yeah, little bit. Okay. Because this is small signal, na. This is only 5 million compared to this one. This is a very small signal. A little bit variation will come.
सर
हाँ.
ये तो हमारे डीसी डायरेक्ट की बात रही है, बट व्हेन वी अप्लाई अ कांस्टेंट पल्स सिग्नल,
हाँ.
तो उसका भी सेम इफेक्ट होगा या
अगर वो अल्टरनेटिंग वेव है तो सेम इफेक्ट होगा। प्लस अगर माइनस है
यस सर
तो सेम इफेक्ट होगा। ओके
सर यहाँ पे रेजिस्टेंस मतलब रेजिस्टेंस ऑफ द सर्किट के बारे में बोल रहे हैं ना?
रेजिस्टेंस वो रेजिस्टेंस डायोड का रेजिस्टेंस की बात कर रहे हैं हम लोग।
ओके सर।
रेजिस्टेंस का सेक्रेटरी ये है, डायोड का रेजिस्टेंस की बात कर रहे हैं। Okay, diode resistance is static and dynamic. Okay, now I want to calculate what is the dynamic resistance. Okay, so for example, if diode is forward bias, okay, so what I can write, the current now this time current will be time dependent if both the sources are present. Okay, let me complete, then you will understand what I'm trying to say. Once the diode you are applying AC input also minimum signal, so then current will be your what, exponential. Okay, now total voltage say VDT on diode. Okay, and that will be what, eta VT minus 1. This is the equation for diode. Okay, now IDT. Okay, now what is voltage across diode VDT? That is equals to source voltage DC voltage plus small signal voltage what we applied is equal. Okay, now you want to write my IDT. Okay, IDT is what IES exponential. Okay, now you can put this VDT value, diode across voltage across diode. Okay, this is voltage across diode, Okay, so that I can write V0 plus VDT, okay, upon eta VT minus 1. Okay, now you can solve it further. Okay, how can you write? You can write IS, okay, exponential. Now if it is forward bias, okay, you can neglect this one. If forward bias, you can neglect this one. So this become now how much? V0 upon eta VT, okay, and exponential VDT upon eta VT. Okay, now what is this one? What is this things? Okay, so now suppose you have a
I not
V reverse
yes.
voltage.
the reverse saturation.
Let's see your diode. This was a resistance, and this is your diode. Okay, when there is only source V naught, then the circuit current is flowing ID. Okay, so ID is forward current that is given by what? IS exponential. Okay, V naught eta VT, isn't it? Are you getting? Only if only this voltage is there, then how to write a forward current? Sorry, this will be now what? This V naught. If diode, sorry, I'm writing wrongly. How much? And so suppose here the voltage is VD. The voltage is here VD. Okay, fixed voltage VD. Okay, so now this will be my current from diode. Okay, similarly now if you write here VD, okay, now if you are applying AC amplitude also, then this will be constant VD plus small VD also. Okay, so now this is your VD. Okay, so now IS exponential VD upon NVT, that I can write as a ID. Okay. So please if you doubt, ask any question.
Voltage across diode में VD plus
Okay, let
नहीं
me
clear
explain. You are not getting. Okay, let me explain once again. See, you have this battery V naught, okay, and you have a resistance R. Here you have a diode, okay. So when I told you the DC resistance, this is my DC resistance, okay, and I told the voltage is here VD, current is ID, so voltage drop is here VD, capital VD. Okay, now circuit current flowing ID. Okay, ID is a forward current, and forward current formula is your reverse saturation current exponential. B is a voltage across diode, eta VT -1. Okay, now for forward bias, what I can write? I can write the ID equals to IS exponential VD upon eta VT, isn't it? Is clear? ये clear है? Okay. Now next time I am putting one more source here. Okay, that is I am calling it VDT. Okay, across diode. So now what will happen? This signal will come here. Okay, so now any signal I'm applying, say any AC signal I'm applying here. Okay, you put AC. What is the problem? Okay, so now here voltage will change. Okay, now this time I'm calling this voltage as a VDT. Okay, or capital VDT. Okay, and capital VDT is what? That is equals to earlier VD when it was this source. Now a small signal more coming, so I calling this like VDT. It is clear now? Okay, now earlier when this is the only thing, we have a this voltage drop. Now when two sources are there, I can write this VD is changing, is small change. Okay, so now for this much, again I'm writing the current. Okay, current will be what? This time current will change. I call it this IDT. This is the fixed current IDT. When this voltage change, this current also changes. So I call it now a small IDT. Okay, now a small IDT will be how much? Again, reverse saturation current exponential this total voltage VD plus VDT. Okay, upon eta VT. Okay, for one I can leave because this is a forward current. Okay, and this I am writing as the IS exponential VD upon eta VT and exponential, okay, VDT upon eta VT. Can I write like this now? Yes or no?
सर एक्सपोनेंशियल में VD प्लस स्मॉल VDT आएगा ना?
हाँ तो स्मॉल VDT तो लिखा है, VD प्लस स्मॉल VDT तो लिखा है, और क्या लिखा है? Okay. So now, so what I'm trying to tell, I am trying to separate the effect of both DC and AC sources. Okay, so that how we when we'll both are present in the circuit, how we'll solve the circuit. Okay, so I want to show when there is a small amplitude. Okay, that time this I can apply superposition principle here. I can separately consider the effect of this one and effect of this one. Okay, that's what I'm trying to solve here. Now this small IDT change current now. Okay, this will become ID. So your IDT, somebody mic is on. This become ID. Okay, exponential small VDT upon eta VT. Okay, now I told you this is a small signal, so this is VDT. Okay, is small is small smaller than your eta VT. Okay, so what I can write, I can write this IDT. Okay, this is ID. This I can write 1 plus x. 1 plus x is that is your VDT upon eta VT. Okay, now your IDT is sum of ID plus ID VDT upon eta VT. Okay, now let me first write the equation, then you can understand what I'm doing. Okay, so now this IDT is equal to ID. This is the total current. Okay, total current because of both the sources present in the circuit. One is AC, one DC. Is a total current, okay, which is time which varying the time because the signal is varying with time. Okay, that is equal to ID current due to this source plus, okay, this is a voltage VDT, small VDT due to this source. How much voltage coming here? Okay, divide by eta VT ID. Okay, so voltage, so this is current, this is voltage, so this is resistance. So now I can write my total current IDT in the circuit will be current only due to one source, due to DC source, plus this is become now VD upon R. Okay, what should I write? This one is a voltage and this become resistance VDT, and this become my resistance. Okay, and this I call as a RAC or R. Okay, R diode, dynamic resistance of diode, which is equal to now NVT upon ID in the circuit.
तो ये एक्स्ट्रा आईडी कहाँ से आ गया?
कौन सा ID?
सर ये IDT प्लस ID
यहाँ उसको खोला ना मैंने, ये ID
इसमें अंदर गया. हाँ,
ID मल्टीप्लाई हो गया यहाँ पे, इसको मैं नीचे भेज दिया भाई. ये पूरा एक्सपेक्ट, ये करंट है, ये पूरा भी करंट है ना, तो ये वोल्टेज है, तो ये क्या हो गया? रेजिस्टेंस नहीं हो गया?
यस.
Okay, so that, so now अब simple story क्या है? What is the simplification I'm trying to explain? Okay, whenever there is a AC source and DC source together in the circuit, okay, the effect of these two sources can be separated out. Okay, once I want to calculate the effect of this source, I will make this as a short circuit. Okay, superposition principle. When I want to see the effect of this source, I will make this diode as a short circuit. Okay, now how can I see the effect of this source? Whenever there's a AC amplitude is there in the circuit, the diode simply can be replaced by a resistance called eta VT upon ID. Are you getting? Whenever there is a battery in the circuit, this VD is there, this is short circuited. Now if I want to see the effect of this DC source, we know how to see the effect of DC source. Either this will be replaced by a short circuit or by battery, isn't it? So once I know this voltage and voltage across diode, I can find this capital ID. Okay, once I short circuit this one, I want to see this effect of this AC source, I will replace the diode by a resistance called eta VT upon ID. Already I know circuit from DC source. Okay, VT I know KT by Q, eta will be given. So if for AC source, your diode behave like a resistance. That's what to tell. Okay, so for AC, whenever you want to see the effect of AC, you have to replace diode by a resistance. That resistance value depends on the ID, capital ID, which is current due to this DC source. and Vt upon I. This is constant, Kt by Q. This constant, and this current. This current is due to the source of your DC current, DC source. Okay. So just हाँ.
सर REC हमने क्या क्या लिख लिया? वो REC तो हमारा चेंज इन VDT और डिवाइड बाय ID था ना?
This is a total current. This is the current for DC source, isn't it?
Yes. Yes.
And this is the current due to AC source.
Yes.
Correct.
Sir.
Now this is the AC voltage across diode. Okay.
सर
So this is
AC वोल्टेज अपॉन AC करंट ही होगा ना? AC REC तो हमने तो इतना अच्छा
this voltage across diode due to AC source. डायोड में कितना एडिशन हुआ वोल्टेज का, उसी से तो करंट का एडिशन होगा ना. See, this is total voltage. This is total. So earlier when only this source was there, here voltage was coming VD. Okay, when you AC source also, now voltage across the diode is VDT. So this is the extra voltage. Okay, so extra current will be what? This extra voltage divided by resistance, and this is extra voltage, and this is this total expression current. This should be the resistance. So resistance, I'm writing this one, diode resistance, NVT upon delta AD. Okay, clear? अरे तो अभी समझ में आ रहा, तो एक इसको एक तरीके से और निकाल सकते हैं. जैसे आप बोल रहे थे डेल्टा which last point? P, this is your voltage, this is total current, this is voltage, this is resistance. So this is the value of this resistance. Diode AC resistance value is given by NVT upon ID.
Not that VD plus VDT. That is VDT is extra voltage.
Yes, VDT is this. This is the when is only this source, you're getting drop VD. Okay.
Yes,
when you're putting extra source, now voltage drop is VD plus VDT. VDT is the due to AC source.
The VDT is due to DC first, and second one is due to AC, and complete is VDT.
Yes. No, I am calculating this another way also. Okay, so note down. Okay.
It is confusing between DC and VD both.
So why how it
signal?
आपके पास में दो सोर्स है, एक सोर्स से करंट क्या करंट मिल रहा है, and then you applying one more source, so current will change or not? Yes or no?
Yes, it will change.
So how much current will change? That we have calculated the formula here for small signal voltage. Okay, this is the extra current is coming. Okay, this is due to this source, and this current is due to this source. This source, how much voltage is coming? VDT. This source, how much voltage is coming? VD. This VDT upon this current expression. So this should be resistance. So I have written this resistance.
Understood.
Okay.
Yes, sir.
Now I am doing this another way also. Okay.
सर AC सिग्नल लगाने पे सिर्फ इसको डायनामिक रेजिस्टेंस से रिप्लेस कर देना है.
बस हाँ, whenever you have a AC source, you have to replace diode by AC resistance. Okay. A small signal, only for small signal. Okay. Because I have taken the condition of small signal here. So I am deriving this one more way. Okay. So maybe that way you can understand. Okay. So I have the equation. I know this is the ID. Okay. ID is what? IS exponential VD upon eta VT minus 1, isn't it? Now suppose you are applying some extra voltage, you're changing this, so what will come? I want to calculate delta AD upon del VD. I am changing this voltage, smaller voltage. Calculate how much is coming, delta AD upon VD, how much is coming? It will come IS, okay, exponential. You can, for forward bias, you can neglect this one. Okay, so how much will come? Exponential VD upon eta VT, and what will come? 1 upon eta VT, isn't it? आएगा नहीं आएगा बताओ?
Yes, sir.
Okay. Now let it be 1 by eta VT. Let it be here. Okay. I want to write the value of this one. IS exponential. Okay. So IS exponential value, can I write this one? IS plus ID. Can I write this value here? Can I write this IS here? Suppose this is -1 here. Okay. Now if I want to write what is the value of IS exponential VD upon eta VT. Okay. IS will go here, that will go here. So I can write this is the ID plus IS, isn't it? Okay. Or you want to ignore this one. So you say I have already ignored. So ignore this one. So I can write like this: 1 upon eta VT equals to ID. Okay. And this is what? This is the 1 upon R delta AD upon will D. So R is be what? Eta VT upon ID. Just now I calculated AC
Yes,
resistance.
sir.
The same thing. Okay. So I this is the easy way, but I was trying to explain you in that way so that the meaning of small signal should be clear to you, isn't it? So I'm trying to say in that method, whenever you have a small signal, okay, that time you can replace and diode by a simple resistance, and the resistance value is eta VT upon ID. Okay, so that's why I did this big derivation. Otherwise, it's one step thing.
Okay, sir.
Okay, you can
Thank you.
directly put this is equal to ID. Okay, remove this one. This is ID, and this is the formula what we have done just now. Clear?
Yes, sir.
This is basically dynamic resistance. Your operating point is changing. Okay, you have some circuit. Okay, so you have resistance in the circuit. Okay, you have this current I V, some current is flowing here, diode. Okay, this VD ID. Now if you change this little bit, this voltage, okay, so this operating point will shift. It will move from here to here. Okay, and this delta ID upon delta VD, okay, this delta ID upon delta VD is your dynamic resistance. 1 by delta VD upon delta ID is your dynamic resistance. So let me solve one problem. Okay, so he says obtain the static resistance and dynamic resistance both. Obtain the dynamic resistance and static resistance. Okay, for that you have been given, okay, germanium diode. Okay, germanium diode and germanium diode is given, and you have been given reverse saturation current IS is equal to 1 microampere. IS is equal to 1 microampere, and the forward bias voltage VD. Forward bias voltage VD is given to you 0.2 volt. Okay, calculate what is the temperature is given 27, that is T is given 300 Kelvin. So find the static and dynamic resistance. So what is static resistance? R. Okay, static resistance is what? VD upon
VD
ID.
upon ID.
ID. So VD you know, ID you want to find out. ID how can I find out? ID I can
IS
find
exponential
VD
d by
upon
eta
eta
VT.
eta VT. Okay, -1. Now let me say what is the value of eta is given. Okay, so eta value T would take 1. Okay, eta value you can take 1. Okay, and VT you can take 26 millivolt. 26 millivolt. So find ID and
जर्मेनियम के लिए 2 नहीं.
इस क्वेश्चन में 1 ही दे रखा है.
Okay.
So tell me how much is ID? So I'm writing the value of ID. ID value is coming 2.185 ampere.
सर R का वैल्यू 91 आता
2 ये कितना आ रहा है? ये आ रहा है क्या?
2.919.
2.19, hi, is correct. Okay, so RD will be what, 200 millivolt, 2.2 volt. Okay, that is 200 millivolt. That is, R will be your 200 millivolts is a volt, and this is ampere 2.185. Okay, ये एम्पियर है कि मिली एम्पियर है, चेक करो. How much is there?
Ampere है sir.
Sure.
सर 0.0197 आ रहा है.
करंट का वैल्यू ये बताओ, ये एम्पियर है कि मिली एम्पियर है, मुझे तो बताओ. ये दिस इज 0.2 वोल्ट. Okay, so this is this should come milliampere, na? IS is micro. How can come ampere? It should come
No
milliampere,
sir,
na?
milliampere.
सर मिलीएम्पियर है.
Milliampere hai. Okay, this is a milliampere. This should come how much? 91.53 ohm. Something 91 point something 53 ohm should come. 200 divided by 2.18.
97.7 91.7 आ रहा है.
हाँ,
91.7 ओम.
हाँ चलो, वो जो भी है 91.7 आ रहा है. It should become almost 91. Clear? Now please calculate the dynamic resistance. Okay, dynamic resistance, how can you calculate? Dynamic resistance RD, small rd, is eta Vt upon Id. Now Vt is what you are 626 millivolt. Eta is 1. Id you calculated 2.185 milliampere. 26 into 10 raised to power minus 3. 2.185 into 10 raised to power minus 3. How much is coming?
11.89.
11.89. Very good. Okay, so it's coming 11.89 ohm. Okay, this is your RD. Okay, now let me show you how to deal this kind of thing in the circuit. Okay, so whenever there is a AC source, you can replace your diode by a simple resistance. Okay, so now say one question is there, this is value, this is the AC source is given, V input, okay, equals to 1 sin omega t. 1 sin omega t. 1 sin omega t means the peak value is 1 volt. Peak value is 1 volt. Okay, and you have been given a resistance 10 kilo ohm, and then you have given a diode. Okay, this diode, and eta value for diode is given 2 this time, and they're asking, okay, calculate the AC amplitude across the diode. AC amplitude across the diode. So how can you find the AC amplitude across the diode? First you have to replace the diode by a resistance. Okay, and then you can find what is the AC amplitude across the diode. So first of thing you want to find what is the resistance. There is resistance. Okay, so first you need to find what is ID, and that is given you 10 volts. Okay, so 10 volt is given. So when I'm calculating due to this source, I can short circuit this source. Okay, so this time the circuit current will be ID. Okay, diode you can replace by silicon 0.2, 0.7. Okay, silicon, so you can replace by 0.7. 0.7. Okay, so now tell me what is ID. ID will be simply 10 minus 0.7 upon 10 kilo. So what is ID value? It's coming 0.93 milliampere, isn't it? Yes or
sir.
no?
Yes, sir.
So you got ID. Okay. Now next thing is what? Next thing you have to see, calculate due to the AC source. Now you have AC source. Okay. 1 sin omega t. 1 sin omega t V input. Okay. Now this time you have to replace the diode by a resistance RD, and the RD value is what? RD value is your eta VT upon ID. Eta is 2, VT is your 26 millivolt, ID is your 0.93 milliampere. Okay, so how much is coming RD? Tell me. How much coming? 53.8 ohm. Okay, this will come around 53.8 ohm, because this power cancel. Okay,
55.91.
53 point
55.9.
भी ये तो आपका 52 हो गया ना. 52 तो
55.91 sir.
55
5.9.
50.5.9. Okay, whatever voltage you are getting approximately. Okay, this is 52 divided by 0.9, so it should come greater than 52. Okay, so now you have this RD value. Okay, now you can replace this by 52, 55 plus 91 ohm. Okay, now you want to find AC amplitude across this one. Okay, so how can you find AC amplitude? So V across diode. Okay, AC amplitude across diode, AC amplitude across diode. Okay, total resistance how much? Okay, you have V input hai, you have 1 into sin omega t. Okay, the total resistance is 10 kilo ohm plus 55.91 ohm. Okay, into I want to find the voltage here, that will be what? 55.91. Are you getting what I'm doing here? So if you want to find the peak value, okay, peak value of this VSC peak value, okay, then you can remove this sign and you can solve this one, and this should come around 5.35 millivolt, 5.35 millivolt. Check it. आ रहा है क्या?
Yes, sir.
Okay. So are you getting what I'm doing? What you mean by a small signal model? Okay, a small signal model is just whenever there is a AC source along with a DC source, and a AC source is very less compared to your DC source. Okay, that is in millivolts. Okay, or very small amplitude. In that time, you can apply superposition principle. Okay, superposition principle का मतलब क्या है? You can separate it out the effect of DC source or AC source. Separate out the effect of AC DC source. Okay, so first you short circuit the AC source and calculate the effect of DC source in the circuit. Okay, that will give you ID value. Once you know the ID value, now you can replace this. When you apply AC source, you can replace the diode by a simple resistance. Now you can do analysis and you can find, okay, whatever this asking in the questions. Okay, I hope this method is clear. Yes.
तो DC बैटरी भी हटा देनी तब.
भी
वो
हटा दी
remove
ना,
कर दी।
भी डीसी वैल्यू का, डीसी बैटरी का यूज क्या था, आईडी निकालना। भी I am not calculating total effect. This is due to this source. Okay, this is due to this source. Now you can find what is now for that. When there are DC source, then voltage was how much there?
0.7.
Very good. That so when
VDT आएगी,
हाँ
जो स्मॉल VDT लिया था, अगर हम
हाँ
बैटरी लगाएंगे वो फिर वो आएगी, अगर हम
टोटल
DC
टोटल चाहिए, टोटल वोल्टेज कितना आ रहा है यहाँ पे डायोड पे, तो ये वोल्ट जो निकाला आपने 5 प्लस वो जो 0.7, आर यू गेटिंग?
Yes, sir. For positive,
Voltage due to DC plus voltage due to AC will come
Yes,
there, na?
yes.
Total.
Yes. For positive, correct. For peak value, okay. We want peak value. And for minus peak value, that will be -5, -5. Very good.
yes, sir.
Okay. So this peak to peak value. Clear? So I'm stopping here. Tomorrow we'll do one or two problem more on this model, and then your diode will be finished. Okay. Tomorrow I will do some problem on other topics also. Tomorrow we'll finish diode by solving some problems. Okay. Previous year's problems. Thank you.
Thank you, sir.
Thank you, sir.